Welcome to Team ASMR's Skeletal Increment presentation for the Wheel of Jeopardy game. Here's an overview of what we will cover in our presentation. We will begin with a team introduction. We will provide an overview of the project, then discuss the Skeletal Increment goals, and outline our subsystems and architecture. We will then go into a demo of the back end and the front end implementations. We will discuss any issues, and then the deliverables and the project timeline for this game. Let me begin by introducing our team. From left to right, we have Alec Wayne as our software quality analyst, Matthew Hayashi, our project manager, Rebecca Wilson, the test and programming lead, and Robert Sand, our lead configuration and architect.
Our ultimate product will be a desktop game which incorporates both the Wheel of Fortune and Jeopardy! This game will have the players spin the wheel, which has several potential outcomes. The player can lose a turn, have to respin the wheel, or choose a category. If the player does receive a category, they will be given the question along with 3 potential answers. If the player chooses incorrectly, it will go to the next player. If they are correct, they will receive the points for the question. This will be played in 2 rounds, and the player with the most points in the end will be declared the winner. Our main goals for our Skeletal Increment was to create the basic logic structure of our game, as well as creating a structure for our graphical user interface. The general architecture of our game follows the pictured logic as a high level. We successfully created this logic in our back end and are currently working on edge cases. One of our key subsystems is the player. This subsystem will hold the important values for each separate game player within the game. The data attributes of name, points, and number of tokens will be shown during gameplay. Another key subsystem is our wheel. The slice, which is randomly chosen during gameplay, will affect the player's options. There are multiple potential outcomes on the wheel, including respinning, the player losing a turn, and the option for a player or an opponent to choose a question category. Our game board design will allow the player to visually see the categories. Our game board contains the categories as well as holding each board box. The board boxes contain the question, the potential answers to the question, points for the question, and if the question is already in play. Our state maintainer will keep track of the rounds, the current player, and the spin counter in order to facilitate the gameplay. This will encompass our essential functions like get or set current game player and contains the functions to control each round, the end of game, and to calculate the winner.
So I'm going to walk through the status of the backend implementation. This demo should illustrate how the classes and functions outlined in our architecture will work together to allow us to build a complete product. I would like to highlight that we predefined the wheel results each turn just to keep this demo concise. Looking at the console, we have 3 players and their attributes. The current player is in brackets. Here's the board and board boxes. This is the spin counter and wheel result. PS question is one in a series of what we call post-spin functions. That's where the PS comes from. There is one post-spin function for each unique value on the wheel. And the transition between post-spin functions is one of the primary mechanisms this demo will exercise. So let's get this question correct. We default that to A. So player 0 keeps the turn, gets the points. The board box is marked out of play. I'm on the next question. So let's get this wrong. Okay, so player 0 loses the turn, loses the points, ends up negative here. And we're on to player 1. Player 1 lands on the free turn slice. So they should pick up a token and spin again. So they picked up the token. Category 5, let's get this incorrect and use our token. Notice that we're only prompted to use a token when the number of tokens is greater than 0. So let's use it. Okay, just to keep this demo going, we'll give player 1 another token, pick it up, answer the question, we will get it incorrect. And let's not use the token. Okay, player 2. The slice is player's choice, so we're prompted for a category. Just to show that we consider malicious input, well, we prompted to enter a category. Let's do 3. Let's get this correct. And business as usual. Okay, so player 2 spun bankrupt, so the points should go to 0 and they should lose the turn. Okay, so player 0 also spins bankrupt, but they have negative points, so nothing happens except losing the turn. Player 1 lands on the actual lose turn slice, but we have that token, so let's use it. And we land on the spin again slice, and we just do that. Okay, so let's get this incorrect. All right, so opponent's choice is like player's choice, but in this situation, category 3 is empty, and this gives us an opportunity to test one of the member functions on the board class that checks if a category has any available questions. So if we try to do 3, it doesn't work, we'll reprompt it, and let's pick a valid one. And that goes through, so let's just answer this. So this iteration should show what happens when the wheel naturally selects a category with no questions, and we just spin again. Okay, so at this point, we have visited all 7 unique values on the wheel and their associated post-spin functions. And since the behavior is as we expect, we will move on from the backend demo.
We are happy to let our stakeholders know that one of our essential goals of creating the system architecture has successfully been implemented. The software development is currently on target. We are now in the process of confirming our backend logic. This will involve rigorously testing potential edge cases, as well as confirming there are no potential bugs within the gameplay. When the backend testing has been completed, we will work on the process of connecting our backend to the front-end graphical user interface.
So this is the current position of our front end. Perhaps the most important thing to mention is the color scheme is not final, but it's useful here because it helps identify certain things. The yellow boxes are the user's interface to the more contained subsystems, so the player's wheel and board. The gray text boxes are representative of the data belonging to these classes. Still, there are a lot of fields that don't come through here in trying to keep a simple presentation. Right now, this canvas is pretty static, like it doesn't reflect the changing states of the backend. However, we have started to connect the two. A good portion of the text is actually informed by constructs we build in the backend, so this is not hard-coded. For example, player names, points, tokens, the current player, the board categories, the board box point values, and the spin counter are all populated by variables. Since we don't yet have the callback function to update the screen components, the text is kind of stuck at the initial value. We made great effort to maintain parity between the console output in our backend demo with this front end, and the motivation is to easily trigger backend functions from user interactions with the GUI, and also update the GUI when these events trigger. Some details that aren't illustrated but are important to mention is the size of text boxes can be controlled by the length and size of text. This is most critical to the board category text box. Another aspect to draw attention to is the spin wheel button. Unlike the backend demo, a wheel spin will be instigated by clicking this button. Otherwise, the front end should preserve much of the automation we've seen in the backend.
On this slide, we will discuss what we want the future state of the user interface to look like. First off, the team wants to make the graphical user interface, or GUI, more aesthetically pleasing. We want to build off of what we have and add more elements to the GUI to make the game as intuitive as possible for the users. We want the game to be easy to play for the users. To the second point, currently, the GUI is not connected to the backend of the code. So the team still needs to put in effort into connecting the GUI to the backend. This will require some more development and integration testing to create a high-quality interface that will correctly operate with the backend. The third item is to create a spinning wheel. The team made it a goal early on to add this animation in, and if time permits, we still plan on developing this piece. This animation will add value by having a more aesthetically pleasing and interactive game board for the users. Up until this point in the project, the team has encountered a few issues along the way that we will highlight in this slide. The first issue being around the graphical user interface development. The team members were familiar with developing backend functions for the game, but all were unfamiliar with the front-end portion, as all of us had little to no front-end development experience. This was highlighted as a risk early on in the project and was an issue throughout development. But to remediate this issue, we found it beneficial to develop the backend and the front end separately. This way, we could focus on developing the backend to a successful state and not halt progress for the project. We did not want to develop both simultaneously, as the integration piece could take away from the development of the logical flows of the game. The second challenge was a programming error identified by the team. So originally, the development did not account for other players being able to answer a question if another player answered incorrectly. So for example, if one player answers a question incorrectly, another player should get an opportunity to answer that same question. But this was not the case in our logic early on. This caused a minor setback in development, but to remediate this issue, the main driver of the code had to be rewritten to account for this logic flaw. Again, this was a small rework effort by the development team. Lastly, the third issue that the team came across was in terms of backend development. So we expected to have most of the backend development completed for the minimal increment. However, the team found that it was easier to implement most of the backend currently to capture the game logic. The team can use the remaining time to test and enhance the current backend portion of the game, as well as further develop the front end.
I will now talk about the deliverables for this project. We just talked about the skeletal increment, where we implemented our backend architecture and the basic GUI design for proof of concept. Next, we will implement the minimal increment, where we connect the front end to the back end and we finish our game logic. After that, we will implement the target increment, where we ensure all edge cases have been exercised and we finished our GUI. Ideally, for the dream deliverable, we will have an interactive game wheel and significant graphics. In terms of timeline, our skeletal increment is on time. We have also begun implementing the minimal increment and will be on time for that. Once we have completed the minimal increment, we will begin the target increment, which is our last and final increment. And that wraps up our presentation. Thank you so much for listening, and we look forward to seeing you in the minimal increment presentation.